What's up? I'm Vin, and today I want to show how to use trig to find the missing angle of a right triangle. So we have triangle ABC here, and the goal is to find the measure of angle A, which is this angle over here. So the trick to solving for or finding missing angles of a right triangle is you got to think about what sides do you know. So if I look here, if I want to find angle A, and we're looking across from angle A or opposite of angle A is side CB that is 27 units long. So right now we know the opposite side and we know the hypotenuse of this right triangle. So then the notes that we need to know the three basic trig functions. And when I think about all of what we were given here, just think about it. We have 27, 48, and I'm going to abbreviate. That's the opposite side, and that's the hypotenuse. So then when we look at the basic trig functions here, we have to think about which trig function uses the opposite and hypotenuse, and that's going to be sine theta. But now think about this is relative to angle A. So I could say sine of angle A is equal to the ratio of the side opposite of A, which is 27 units, over the hypotenuse, which is 48 units long. But now remember, the goal is to find the actual measure of angle A, and we're rounding to the nearest tenth of a degree. So then to get the angle A by itself, to solve for A, to find the measure of angle A, we have to do the opposite of sine, which is sine inverse, or sometimes people will call it arc sine. So we're doing sine inverse of the ratio, 27 over 48. Okay, so just know in general, the term inside of a trig function, sine, cosine, tangent, or some other one, is the angle, and it sends you to the ratio. So anytime you want to solve for the angle, you put the ratio inside of the inverse function, and it tells you what the actual measure of the angle is. So that tells us the measure of angle A is equal to, and we're just going to go ahead and type in sine inverse is second sine, and we've got 27 over 48. So to the nearest tenth, that's going to be 34.2 degrees. So this is 34.2 degrees. So that is the measure of angle A. So for the second example, now we're looking at triangle DEF, and we want to find the measure of angle E down here. So for this one, we just want to follow it the same way. We want to think about what sides were we given relative to angle E. So this side here, FE, which is 67 units long, is the side adjacent to angle E. So this is the one right next to angle E. And 77 is across from the right angle, so this is the hypotenuse. So now we just want to think about these two phrases together. So this is the thought process for choosing the correct function. We were given the side that's 67 units long, that's the adjacent side, which we'll abbreviate with these letters here. And we were given the side 77 units long, which was the hypotenuse. So when you hear the phrases adjacent and hypotenuse, that should make you think of the function cosine. So now we're doing cosine of angle E is equal to the side adjacent to angle E, which is 67 units, over the hypotenuse, which is 77 units long. Notice this side over here, DF, is the side opposite of angle E, but we don't actually need to know the length of this side to answer this. We just need to use the sides that were given to us. So now from here, we want to solve for the measure of angle E, so we need to get rid of this cosine function here, and the opposite of cosine is cosine inverse. So we would do cosine inverse of both sides. So we're going to take cosine inverse of 67 over 77, and let's see how this works out. We have cosine inverse of 67 over 77, and this works out to 29.5 if we round to the nearest tenth. So our final answer here is going to be the measure of angle E is equal to 29.5 degrees. Just make sure we write the units in. So this is our answer to the second question. So for this last question here, we're looking at triangle PQR, and we want to find the measure of angle Q. So for this one here, we're going to start off the same way. We're looking at angle Q, and we have to think the side over here, PR, that's 6 units long, that's the side opposite of angle Q. And the side that's 8 units long over here, RQ, is the side adjacent to angle Q. So we just have to think about now what we were given. We were given the opposite side, and we were given the adjacent side. So the thought process in this question, when you're thinking of these two sides, when you know the opposite side and the adjacent side, the function you want to go with is tangent. So this is the one we're going to use. So we're going to have tangent of angle Q is equal to the side opposite of Q, which is the side that's 6 units long, over the side adjacent to Q, which is 8 units long. Now, if you want here, you could reduce. Tangent of angle Q is equal to 3/4. So then when we want to solve for the measure of angle Q, which we use this notation here, remember this means the measure of angle Q is equal to, and to get rid of tangent, the opposite of tangent is tangent inverse. So we're doing tangent inverse of the ratio 3/4. And this is going to tell us the actual measure of angle Q. So let's just go ahead and punch this in. We have the measure of angle Q is equal to tangent inverse of 3/4. So now we're just going to round this to the nearest tenth, and 36.86, this tells us to round up to 36.9. So our final answer here, we have 36.9 degrees. Now, one other thing I want to mention here is that another option would be to solve for the missing side here. And notice this is a 6, 8, 10 right triangle. I could use Pythagorean theorem to solve for PQ, but it is going to work out to 10 units. So what that allows us to do when we know all of the sides is, let's say instead of using tangent inverse, I wanted to use sine inverse. So when I know all three sides, I could use any one I want, and I could look at this now. Opposite of Q is 6 over the hypotenuse is 10. So this would be if I wanted to use sine inverse, and notice if we do sine inverse of 6 over 10, this is going to give us the exact same answer. And along that same line of thinking here, let's say instead I wanted to use cosine inverse, then I would have to look at the side adjacent to Q, which is 8 units, over the hypotenuse, which is 10 units. And if we punch that one in, cosine inverse of 8 over 10, that's going to give us the exact same answer. Okay, so when you know all three sides, there is some flexibility. You have options in terms of which function you want to use. Okay, well, this is going to conclude this video on using trig to find missing angles of a right triangle. If you found this video to be helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topic or topics you want me to cover in the comment section below. And thanks for watching.